Welcome to today's lesson in Engineering Science Info. Today we'll be looking at the section called Kinematics. We'll be focusing on resultant velocity. This question is taken from the July 2022 past exam paper, question number 1. It reads as follows. An aeroplane flies to its destination 300 kilometers directly east of its starting point. The pilot wants to complete the flight in 15 minutes. There is a southwesterly wind blowing at 10 meters per second. Calculate the velocity of the aeroplane and the direction of the flight. Lies the question. Okay, we are given that the velocity of the wind is 10 meters per second. Okay, we are asked to find the velocity of the aeroplane. So in the question we are told that the plane wants to go east and it's moving at 300 kilometers and it's moving for 50 minutes. So the first thing to note here is what is the correct units that we should have for time and distance or displacement. That is determined by the velocity. If we look here, we find that the velocity of the wind is in meters per second. So since the velocity of the wind is in meters per second, it therefore means that our distance or displacement should be in meters and our time should be in seconds. So the first thing we need to do is do a conversion. Okay, so to convert from kilometers to meters, we're going to multiply by 1,000. So 300 multiplied by 1,000, the distance or displacement here is 300,000 meters. The time is in minutes. It should be in seconds as our velocity is in meters per second. So that means we are going to convert from minutes to seconds. 50 times 60, the time is 3,000 seconds. Now, the most important thing to understand in this question is we are trying to find the velocity of a plane. The plane wants to go east. Okay, we already know the time, we already know the distance, we already know the landing point of the plane. Since we already know the landing point of the plane, the time and the distance it takes, that means in the question we have already been given the resultant velocity. So this is a question that is working in reverse where you have been given the resultant velocity. You are now asking us to calculate the velocity of one of the objects, in this case the velocity of the airplane. So we want to know what is the velocity of the airplane as it's moving towards its landing point. So you should now be using this distance and displacement to calculate the resultant velocity. The formula that we can use for velocity in this case is displacement over time. So my resultant velocity is going to be 300,000 divided by 3,000. So the plane has been moving with the resultant velocity of 100 meters per second. So since we have this, the next thing we are now going to do is draw a diagram on the x and the y axis. Okay, so here's north, east, south, west. Okay, so if we look from the starting point, okay, there is a wind that is blowing from the southwest. So if there's a southwesterly wind, okay, let's think about this. The wind is coming from the southwest. As the wind comes from the southwest and it touches on the aeroplane here, that means the aeroplane is no longer going to remain southwest. The aeroplane, together with the wind, is going to go to the opposite direction. So as the wind blows, the wind does not remain in one position. Okay? The wind will automatically move in the opposite direction. That is why I have drawn the wind in between northeast. So as the wind moves from southwest, it will land northeast, and we know the wind is moving at 10 meters per second. Again, since the wind moves from southwest to northeast, it means the angle for this object is 45 degrees. Okay, and if you would like to understand why or how this angle is 45 degrees, then you can go and watch my previous video on kinematics on relative velocity, which explains to us the reason why the angle is 45 degrees. Okay, so I draw the angle here, right? So from north to east it's 45. That means on the horizontal plane here we say 90 minus 45. The angle here is 45. Okay, we also know that the plane wants to head east. Okay, so from its starting point it wants to go east. This is the main part of the statement. Where does the plane want to land? East. So now we need to ask ourselves this question. If we are the pilots and we are flying this plane and we are currently at this point here where we have started to fly, okay, the wind comes and blows on us and takes us in this direction if we are northeast. Now from northeast we have to fly this plane to land east. What do? We need to draw an arrow that will help us go east. It's like drawing a map. Okay, which way will you draw on this map to land east? If we continue flying upwards, we will continue to move northeast and we will not reach our landing point, which means in this case, we cannot continue to move northeast. Okay? In this case, it means if I am at this point northeast and I want to go east, it means I now need to move downwards. So when I travel down, I would now land at my landing point, which is east. So the plane needs to move east. So in this type of a question, if you do not have the magnitude and the direction of the airplane, you have to draw the diagram of the landing point and the wind, and those two directions will then help you to see the direction you as a pilot would need to fly the plane to go east. All right, so in this case, once again, I'm at this point at the top, the plane is northeast, the wind has blown me northeast. If I want to come to east, east is my landing point, I need to move downwards. That is why I'm drawing the plane going downwards. Okay, now we would notice we are not using a right angle triangle. So since we are no longer using a right angle triangle, we can no longer apply the vector method. We cannot break up each component into its vertical and horizontal component. When we are using a triangle that is no longer right angle, it means in order to find the magnitude and direction, I now have to apply the sine and the cosine rule. So I'm going to label the three sides of my triangle. Okay, this is my aeroplane. So where my resultant, I'm going to go in a clockwise direction. Where my resultant velocity is, this is side A, the wind is B, and the airplane is C. Then I'm going to label the angles on the opposite side. So this is angle C. This is side C, angle C. This will be side A, directly across it is angle A. And the wind is side B, and this is angle B. Okay, so since I'm not using a right angle triangle, to calculate the magnitude, I can now use the cosine rule. And we know that we label this aeroplane as side C, so we can say C squared is square root A squared plus B squared minus 2AB cos of angle C. Okay, so side A here is my side A, B, and C. All right. So I'm going to substitute and I'm going to say 10 squared plus 100 squared minus 2 times 10 times 100 times cos 45. So if I look at C, directly across C, I have this angle as 45 degrees. Okay, when I punch this into my calculator, I get it as 93.198 kilometers per hour. Okay, that only helps me to find the magnitude. When I want to find the direction, I can now apply my sine rule. So we know it's sine A over A is equal to sine C over C, which is equal to sine B over B. Since if I look now, there are two angles I need to find. I have angle A and angle B. So we need to ask ourselves this question: where does the plane want to go? Does the plane want to land at the top, which is continuing northeast, or does the plane want to land at the bottom, which is east? Since the plane wants to land at the bottom, which is east, okay, I'm coming downwards and I'm going east. The angle I'm trying to find is B. So here I'm going to use the angle I have is already C. So I'm going to say sine C over C is equal to sine B over B. So sine B is the one that I have. Side C is 10. So sine theta over 10 is sine 45 over C, which is 93.198. So my angle is going to be 4,351 degrees. And we still need to state whether it's going north, south, east, or west. So what we need to do is we draw a diagram out here. It was landing east. We know it was going northeast. And lastly, the plane came downwards to land east, because east was my landing point. Okay, so if I draw this on a Cartesian plane, this is east. Okay, from the top, you moved in which direction? From the top, you headed this direction to go south, to go east. So this direction is actually going to be southeast. So the direction we are actually moving is going to be east, 4.351 degrees south. Thank you for watching today's lesson, and if you'd like to receive more videos on this section, which is kinematics, or the subject engineering, science, and 4, you can subscribe to this channel.